what?
Yeah.
All right.
Lock in 3, 2, 1. All right. Well, let's see. We just need to show this essentially. Can you guys see my screen?
Yeah.
Yep.
Yeah, I see it.
Yes.
All right,
Lower
for sure.
back. Oh my god.
So show that somehow the force on the loop is this guy. How in the world are we gonna do that? You might ask.
Which guy?
Plug and chug.
Good question. All right. Well, I could tell we're gonna need to integrate. That's for sure. That'll be fun. So, all right, let's go at it. So let's see what the book says. So you're basically saying that.
We have to take a line integral of every side.
Essentially, yeah. All right. My brain's probably going to be working only for the next 20 minutes. So if I somehow start mumbling nonsense, just stop me, and then I'll hand over the what's it called thing to someone else. I'll hand the baton to someone.
If your brain stopped working, then I think we just call it a session.
Sure. Let's try going at it though as much as we can. All right. So let the force on the loop be F1 plus F2 plus F3 plus F4. Well, that makes sense, right? Because you have force. Well, why is the force like that though? If we're doing the let's see. So how come force?
Because the book says.
That's a reasonable explanation, but is there an alternative explanation to that as well? Probably not. Then okay. Oh man.
God.
No, because I understand, we know that, there's current and there's something with, the right-hand rule. Let's see, force and the right-hand rule. Let's see what that is. All right, so force is perpendicular to both U and B. What's U? U is the velocity vector of, what, hold on. Is U the direction of the current? What's U supposed to be? Is that the velocity of the line current? I think so.
Yeah, U is normally velocity in this.
Yeah, it's probably the direction of the current perpendicular to that. You get the force, I guess.
Oh, it's moving with velocity. Okay, yeah. So it's the direction of the current. So let's just say that. So let's just remember this. F equals. All right, don't say this. AF equals AU cross AB. Okay, that's it. I'll just remember that. So the force is perpendicular to both the velocity vector and the magnetic field. Well, let's see. If we know the magnetic field going boom boom this way, what in the world? This is fun. Okay. Yeah, it's interesting to know why the force is pointing out of the page. I think that we'll just memorize this honestly for tomorrow. Just memorize it. The force.
Well, I'm thinking maybe if you have thumb up and fingers out, maybe something like that.
Interesting. I'm trying to see because so the current and I curl my fingers. Let's see. So I'm curling the fingers. So that's the direction of the magnetic field. I know that. But how come the force is? You know what?
Wait, so the AU, where is that pointing?
AU is the direction of the current.
Okay, AU is the direction of the current, which is pointing up, right?
Yeah, it's pointing in the Z direction.
Wait, okay, one second.
And then the AB is pointing where?
That's the direction of the magnetic field flux, and I have no idea where that is flowing. Well, this is something interesting, actually, because the force is equal to the current cross B equals F, which is very interesting. And I'm trying to understand why in the world F is pointing in a certain direction. is.
Okay, give me all your questions, and I'm gonna type them into ChatGPT and see if we can get an answer.
Okay, sure. Yeah, just tell me. How do I know the direction of the force based on direction of the current? How's that? It might have something to do with the parallel thing over here. I don't know. Let's see.
And what? Just list off questions like, oh, the AB. You said you don't know where that's going either.
I have no clue where AB is coming from. Like the direction of the unit direction of the field. That's something interesting I'd like to know.
I might
Let's
plug
see.
this thing on Chegg and see what the experts have to say.
You know what? I think I know. I think I know actually. All right, I get it now. I get it. All right. So for the first one, let's see. So if current here is flowing, all right, so we know that the magnetic field, if we do the right hand rule, magnetic field here, I'm gonna draw it in green, it's gonna flow in this way, in this direction. It's gonna like go around the blue line. And it's gonna be same thing over here. So it's gonna go, let's see, boom. It's gonna go
Martin, are you recording this?
that way. Let's see. And then this is just going out from the right. This is out from the right and in through the left. And then this is going, let's see. And then this, let's see. So it's going out from the bottom. Yeah, let me just make sure. Yep, out from the bottom. Yep, out from the bottom. So it's going down from the top and out from the bottom. There you go. Okay, so that makes sense. All right, so and also the current here. Let's see. So because it's going this way, so it's also gonna this way. Okay. All right. So let's see. Let's draw our cylindrical coordinate system. So we have basically rho, phi, right, and then you have your z. So if we see the current in the first one, AZ, the current's flowing in the positive z direction. The the magnetic field flux, it seems like it's flowing in the positive a phi direction because it's rotating this way. It's going this way around. So it looks like it's going in the a phi direction. If you cross those two, is it by chance you get negative a rho? If that's the case, then this would make sense because you see F1 pointing in the direction of minus a rho.
Wait 1 second. Wait. Okay, so list out from like if you have 0, 0, 0, what's the first 0 represent?
0, 0, 0.
Like within the
Oh,
cylindrical
these are
coordinate.
just little. Oh, so these are just little arrows that represent the direction of the magnetic field.
Yes.
No, I'm saying is it like
arrow
phi rho z or is it rho phi z?
Rho phi z. That's the coordinate.
Rho. So z phi would be negative a rho, yeah.
Okay, so there you go. So that makes sense.
Okay.
So that's why F1 points that direction.
Could you just
Now,
briefly go over that one more time? Just
oh,
overview.
for sure. So we know that the direction of the force is going to be the direction of the current cross the direction of the magnetic field flux. So we see in the first segment, which is this vertical line on the left where the I2 is, you see that the current is flowing in the AZ direction. We use the right hand rule for the magnetic field, and we see it curls in the positive A phi direction. And you cross those two, you get your negative a rho, and that makes sense because you see the F1 vector pointing in the minus a rho direction.
Yeah. So the arrow for the direction of the current is where your thumb goes, and then your fingers follow.
Exactly, yeah. And then your fingers curl in the direction of the magnetic
Of
field.
the force.
And then
Yeah.
you cross the two, you get your force. That's the way I understand it.
Oh, so current's in the z direction.
Mhm.
Phi or the magnetic field is in the phi direction, and so that means that it's in the rho direction. Okay, cool.
That makes sense to me. If you guys have another explanation, then go for it. But
Nope,
that's
that
all I
makes
see
sense.
for now. Okay, so then we just basically follow the same logic that if this is pointing out this way, then we don't need to repeat the analysis for 2, 3, and 3, 2, 3, 4, because it's basically just the same conclusion that, okay, if current is pointing this way, then by default, force is always going to be this direction. That's just by
Yeah.
default. So that means that you could just basically copy and paste the same analysis, and you see the force is always pointing out. So that's basically what we got.
Like a flux on the magnetic.
Essentially.
Yeah.
Yeah, so this is basically the same argument. I'm writing like a professor would right now, but hey, it actually makes sense. Okay.
Dr. Sun 2.0. I'm just kidding.
All
Hey, at
right.
least your
So
diagrams make sense, unlike Dr. Sun's.
my diagram?
Yeah, yours are actually better than the book.
I'm not this is the diagram straight from the book. I'm just adding these little arrows to kind of try to like break it down simply what's going on.
Yeah, but that's what I'm saying. You added these things to make it simpler.
Oh, okay. Well,
Just
that's what it
compliments
should do.
your drawing skills.
So now the force on the loop is basically F1 plus F2 plus F3 plus F4, right? Like that's just by default because that's just it.
Mm-hmm.
I think like that makes sense. If you want the force of the whole thing out of the loop, well, just add F1 plus F2 plus F3 plus F4. There you go. Nice. And might as well make it vectors. All right. And we know that every single force basically is going to be what? It is going to be. Oh, this is going to be nice and interesting. Okay. So, we can go ahead and look at our analysis sheets first of all. Let's see, F1, F2, F3, F4. Essentially, what is this? I have no idea. But what I do know is that the first thing we could do, if we have the infinitely long wire over here, which is, that guy, we have a formula for it. So this is line. I'm going to call this line. So F line is equal to, this is an infinitely long line. This is just I over 2 pi rho a phi. That's just the formula that's just, by default given to us. And so that's H. Oh, no, that's H. I'm sorry. What am I saying? That's not F. That's H. Yeah, that's H. So if you want to make that B, you have to add in the mu naught, essentially. Reason being is because B equals mu naught H. So we just basically put in the mu naught. Okay, so that's our B. All right, and now to get the force, we have to actually do the cross product of. It looks like. No, do we have to? We don't have to. Well, yeah, we have to do the cross product. Yeah. So. Well, first of all, what do we know? We want to essentially investigate what's our rho and what's our I, first of all. Well, we want to investigate what is the force on the loop due to this wire. And so if that's the case, we're going to have to go ahead and basically look at these parameters over here. And it looks like our B1 is going to be that, and our B2 is going to be this. I think so. Yeah, let's see. I'm just trying to read through this and understand it like simultaneously. Like I'm trying to explain and read, but it's not the same thing.
You're doing good, Michael.
Thank you, appreciate it. Let's see what we got here. Let's see. This is very interesting. All right, I'm just gonna write it all out actually, and I'm just gonna try and make sense of it as we go along. How's that? I think that's a good idea. All right, so there's an I2, a scalar I2, and then this is not a typo, I think. I don't know if it's a typo or not, but they also make it DI2 cross B. If you guys see that as well. B1.
Yeah.
That's just like
Yeah.
the vector form of it, right? Or because it's like
Yeah,
in
that's the vector form,
Is
yeah.
I
that
think
the
it's
length?
DL2. I don't think it's DI2.
Yeah, that's
It's
DL.
DL2?
Mm-hmm.
Yeah, it's DL2.
Oh, you
Yeah.
could be right. Yeah.
differential length.
Okay, yeah, you're right. Why is it the L2? What's L2 though? What's L2? Is L2 the
line-
length of the?
The direction, I think, that we're going in F1, like in I2, that's
What is that, like X of
is in the Z direction, the positive Z
yeah,
direction.
Z.
Yes, that's true. All right. So that's going to be the case for F1 and F3. And then what's F2? F2 is a different force. That's going to be d rho and dp. Okay. And then what do they have here? They basically say where you have.
Mhm.
All right, this isn't bad actually. I think is it? No, it's not. Wow, this is very nice. So how come? So they integrate from p plus a to. All right, let's go for it. Let's truck it along. All right, so this is it basically right here. So we're gonna tank the length essentially. So we know that just the general formula. We have f equals the integral of I dl cross b. I think that's like the general formula, and then it's like a closed line loop. Is that like the formula for like the force? Is that like a general thing? Yeah, I think that's right. Awesome. So that would make sense because we're trying to find the force on the loop. So we're gonna need the current from the loop as well. So the I is gonna be from the loop. And what current is from the loop? The current from the loop is I2. So that's why we have that. And then what magnetic field force is causing it? B1. And B1 comes from I1. So that's probably where that makes sense. So this B1 essentially is coming from this I1. And then the current from the loop has to match the force in the loop. So that would make sense as well. And then each length is going to be a differential length. We're going to have to calculate the length essentially from F1, F2, F3, F4. That's the only thing that really changes. Everything else is going to be the same. So we know B is, this guy right here.
Which guy?
This guy.
Wait, it's rho naught. Do you see how it's rho naught plus a in the?
It's rho naught plus A in some places.
Oh yeah, no.
Yeah, in
That's
some.
F3. Sorry, I was getting ahead.
No, you good, you good. And then we have just integrated differently. Okay, so yeah, because so let's start with F1. All right, this actually starts to make a little more sense now. So F1, let's start with this one. So I2, that's going to be taken out because that's always constant no matter what. Your length, what direction is F1 going towards? Let's see. F1 is pointing in the. Well, no, we have to take it's the length of the current. So this is going to be the DL is in the direction of the current. That's always going to be the case. So DL is the right direction of current. So that would basically be DZAZ would be your differential thing. Yeah, that'd be the case right there. And then we're crossing with B. And here's the thing. B is always so when it comes to B, your rho naught is not going to change. So this rho naught here, like this is always going to be rho naught for this case because the rho is not changing. The z is the only thing that's changing. And so we could just do mu naught I over 2 pi rho naught. And what's I is? This is I1. We have to make sure this is I1, by the way. Let's see. Make that I1. And this is in the A phi direction. Hey, we literally did this right here. AZ cross A rho. That's or AZ
Oh,
cross A phi. So maybe they just made a guess that this was going to be the case, but hey, I mean, there you go. So you got I2 integral. Let's see. So this is now going to become the following. Oh yeah, and we're integrating with respect to z because you see how the z is the only thing that's changing because we're going from z equals 0 to z equals b right here. B. So we have to go from this to this. And when you actually do this math, which I'm actually going to do because I want to make sure I know what I'm doing, this is going to be um, rho naught I1 over 2 pi rho naught dz. And this, oh yeah, and this is minus AP. A rho, and we'll make this negative, put it out here, dz. And so you do this, and 0, that just makes the whole thing go to 0. So you're left with negative mu naught I1, I2, tag on the B somewhere, and over 2 pi rho naught equals F1. Nice, huh? This is nice and clean. Okay. Now let's do F2. What's going on in F2? F2, we have I2. It's going to be the same thing again. So now here, the Z is constant. So what we're doing now, we're seeing how this is pointing in the rho direction. So we're going to have to basically do D rho, A rho, cross our, normal thing that we just did again. This B1's always going to be constant. It's just going to be plugged in here the whole time. But now the rho has to be variable. It's not just rho naught anymore because now we're integrating from rho naught to rho naught plus A.
Okay.
So
Wait,
now we're
where's the plus A come from?
So start from here. This is rho naught, and then when you get to here, we've added a distance.
Oh, I'm an idiot. I didn't. Okay.
No, you're fine. My handwriting's like all over the place, so you're good. This is rho. Yeah, so that's just not going to change ever, I think. So now what we have is A rho cross A phi equals AZ. And you know what? That actually makes sense because you see how F2 is pointing in the AZ direction. There you go. So we know we're doing something right. And we have to integrate rho from rho naught to rho naught plus A. All right. So that's good. All right. So this shouldn't be too bad. So I2, let's see, integrate from rho naught to rho naught plus A. Okay, so this is going to be this I1 over 2 pi. Or actually, I could take this whole thing out of the integral. The only thing left in here should just be the rho. So let's take mu naught out. Mu naught I1 over 2 pi. And we're just left with 1 over rho AZ in here. Rho from rho naught to rho naught plus A.
Take the natural log of that.
Yeah, that's just basically it. So what are we left with? It's just basically mu naught I1 I2 over 2 pi times the natural log of let's see, mu. Oh no, this is rho naught plus A over rho. Is that right? I think that's
Yeah, because
Rho
when you
naught.
when you subtract them, the two natural logs, then you can combine those together and make a division.
yes, sir.
Yes.
All right,
And then
so
don't
that
forget the direction.
yeah, the direction too. Yeah, AZ. All right, this
I
is
see.
equal to F2. Very nice. All right.
So if I'm remembering correctly, it was supposed to be like ln p naught plus plus alpha minus ln of p naught.
Yeah. Yeah,
Okay.
yeah, yeah. So that would be
All
this
right,
guy.
that makes sense.
Yeah, then we could just bring them together and divide out. Okay, there we
All
go.
right.
It's a good sandy check. Good sandy check. Let's see. So F3 now, it's the same exact thing. We're just gonna, let's see. Now we're going in the negative DZ direction. So this is minus DZ, AZ. Let's see. And the rho is constant. So here now we're at rho plus A. And so we're going to go ahead and stick rho plus A in here. We just have to be mindful of our variables. And now we're going from Z equals B to 0. So now we got to, we're changing the bounds a bit here. But no worries. Wouldn't it technically be the same? No, you know what? I'll do that later. I'm not gonna try that right now. Oh yeah, this is A rho phi. So what's AZ cross A rho? That's negative AP. So if we have a minus AZ cross A rho, wouldn't that just be positive AP? That would make sense, yeah, because then the F3.
Yeah, it's positive. Yep.
There you go. Okay, so I2, and then could take this entire thing out, honestly, over 2 pi. All right. And then this would be your positive AP, right? So this is just a rho, and then all we're left with now is just basically, okay, do your, no, yeah, it has to be with respect to, this is your D rho, A rho. No, there's no D rho, it's just, wait on. So let's see, DZ, yeah, so the D rho has to still be here. I can't believe I forgot that. And then the DZ is here, DZ A rho. Okay, just quick sanity check there. So this would eventually be 0 minus b, so we just add a negative b here. So this will be negative mu naught I1, I2 over O and b. Don't forget b because it's minus b. It's basically the entire thing here times minus b. 2 pi rho naught a rho, and this is F3.
They have it as positive in the book because
Positive.
they left DZ as positive, and I don't know why.
All right, that's a good thing to figure out right now. Good
I
question.
hope
Why
My brain is now braining right
It'd also be like a typo in the textbook.
honestly, it could
now.
be.
That's the thing. That's the thing, because there are typos in this textbook. There's so many, bro.
Yeah, for like 5 homework assignments, or for 5 problems in a homework assignment, it was like all incorrect answers.
I'm gonna keep working this, and then whatever we get at the end, we're just gonna get. How's that?
Sounds
Yeah,
good.
I
I
agree
think
with that.
right, Michael. I think the book just don't know. This book is unreliable.
Michael is smarter than the book.
Yes.
Sure.
Uh,
Trunks.
You can't call freaking Michael Unk. Michael's like baby.
I'm like, I'm your guys' nephew, bro. Like for real.
Trust the little unk. There you go.
He's a young unk.
He's a yunk.
Young unk.
How about trust the young punk?
Yeah, there you go.
Michael, you don't need to start
There you go.
nephews now.
This guy. Oh man, I
Uh,
too. We're going now from. Let's see. We're going from rho equals rho plus a. You know what? No, I want the. Will, do you want to figure this one out? Like, tell me what to do, like Dr. Baker.
Does everybody want me to figure this out? Or no?
Yes.
Okay. All right. I'm just gonna read off what I see, and Michael just writes it down. Okay. So basically, we're given the B1 is the magnetic field flux, right?
From what?
So if we look at the chart, right, on 4, okay, so P is going to be changing, so it's a be a variable. So we got actually, let me look at right here. So it's not gonna be P constant. It's gonna be P, and then basically our boundary conditions when we're integrating over this line is going to be from the top end is going to be from P naught. We start from P naught plus A.
I think so. Yeah.
A to
And,
B, yeah.
and that is be P naught because basically we're going since we're going backwards, we're going to the left hand. So at the biggest part is we're starting from P naught.
It's rho.
P naught plus A, yeah, and then we go to P naught, yeah.
Yeah.
It is, bro. I forgot. Oh
Is it bad? Is it bad? Yeah,
It's
yeah, it has to
Pope
be
zero.
field 4. Yeah, because look, we're starting from P naught plus A, right? Because starting from the right hand side, and that's given on the line, and then we're trying to end at P naught. Yeah. So now if we look at that, we're changing in the road direction. We're gonna and since we're in the road direction, we're gonna do DP AP cross product with the B1, which is U naught I1 over 2 pi rho. You know the book? Yes.
Wait, which one were we talking about? Number 4?
Because
Now
we're
here's
going
the
to the negative. We're going okay, so we're going negative rho. So it's gonna be pointed that way. And then
all right. I think I know what the issue is. Sorry,
we get
Will.
a
I'm gonna
negative
cut.
Z. We get a negative Z.
I think
Negative AZ in the direction.
the book's right. Actually, I think so. Reason being, I see why. Because uh the DL direction here, that's not, it's not like basically saying okay, like, because like all we're given when we have DL, like if you read the book, it's just DX AX plus a DY AY plus DZ AZ. We essentially take care of the negative when we change the bounds of integration, because if we keep this negative here and we have a z to 0, a b to 0 over here, that's basically the same thing as f1, where it's from 0 to b positive. But we know that they're not the same thing, so we're
Oh.
essentially take care of that already. So the book's actually right on that, and it makes sense because the answers they get, it's like reverse subtractive. So all we need is just we already take care of the negative sign by our bounds of integration. So all we need to know is just okay. Tell me which direction we're going in, and just cross it with your B1.
Yeah, and that makes sense because if we look at 4 right here again, so boom, if we just look at it like, okay, well, we know we're going in the negative row direction, right? So we're going to the left hand side, and then we're still on the positive side of the phi. So when we curl that, um, we get it in the negative z direction. But since our boundary of conditions is backwards, uh, there's also going to be a negative produced in itself, but the two negatives cancel out, so it becomes a positive.
Yeah, it's just basically
Yeah.
just tell me what direction it's in. Essentially, is it X, Y, Z, and then you let me know if it's negative or positive based on the bounds of integration. Other than that, like, don't think if it's positive or minus. Just put the positive in there, and then you just direction is determined by bounds of integration, and that should be it. So let's just finish the problem basically. Yeah. So we got D row, A row, and then you said, well, what we're changing is the row, right? Or the P, or whatever you want to call it. So
Yeah.
all
Yeah.
right. And then that's there. All right. What's the next step, bro?
Convolution. Oh.
Stop and try.
Is this an LTI system?
Yes. We have a system here. Can we test if it's stable or not?
All right. Here's our unit step right here. These are our two unit step functions, a row. So a row is less than 0, and a phi is greater than row. All
Okay.
right. Let's change the pump.
Stop. Oh god. Only you're killing me here.
This is
Unk.
PTSD.
Dr. Baker's the OG Unk.
Yes. So we do the cross product. Okay, boom. So we look at this. Okay, so phi is going in the in the negative direction. All right. And so that's going to be left. So boom, that becomes negative AZ.
So this becomes negative AZ?
Yes.
Well, not necessarily.
Then why'd you ask me?
Right.
Yo, what's going on?
It's untouchable.
Because it will become negative AZ when we plug in the bounds of integration. But as of right now, we're just basically asking what's row cross phi
What is row cross
Yeah,
B?
because AP.
z.
Okay, if we want if okay, so since it has it as positive, right?
Uh-huh.
So we have it. Okay, boom. So it's coming towards us, and then phi is positive. Boom. So it becomes AZ.
Yes, sir. Awesome. There we go. All right. So, how would you solve this integral?
Oh yeah, take everything since we're taking the antiderivative with respect to rho. We take all the constants out. Boom, and we just left 1/rho, and we just take the antiderivative, and that would be the natural log of that. And
Yep.
That makes sense. Yep. And I have to keep the D row here. I keep forgetting the D row, my little integrator. All right. There we go.
so
Nice,
yeah,
nice.
where does the negative sign come in?
Negative sign will come in basically this way because let's see. Yes, yes. Nice, nice, nice. Blah 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 blah. Awesome. Yeah. So basically, you can change this integral to be like the second one where we have
Okay, so
this.
you want to flip the boundary condition, so you want to put P naught plus A over,
Uh-huh.
and then make that negative.
So you make this negative and then you make the boom. There you go.
Peanut.
That's how the book does it as well. And then you're basically going to get the same thing as F2.
It don't.
Well,
Mm.
not the same thing as F2, but you'll get um you won't get
You'll
the
get
same thing as F2, but you'll get the negative version of it,
yeah,
which
you'll
makes
get the
sense.
negative version, which makes sense.
Yeah, that's perfect.
Why does it make sense? Because that's how it is.
Yep.
So if we
We just
did
have
it
to
the other
accept that.
way, it would have just been the same. We just had the positive.
Essentially, yeah. And this is this. All right, so now how do you prove this equation right here? Well, what do you need to do? All right, well, let's see. First of all, let's just add F2 and F4 together. This guy and this guy. What do you guys notice about these two?
They go
They're
away.
repulsive.
Yeah, this one's positive, this one's negative, so that goes bye-bye. So what are we left with? Just F1 plus F3. And we could see that there is a difference. There is a difference.
Yeah, I was gonna
So
say like
let's
a
actually.
millimeter.
Wait a minute. F1 plus F3?
Mm-hmm.
Don't
Because of
those
this.
cancel?
Yeah.
F1 and F3. F2 and F4 are parallel, right?
Yeah, so F2 and F4 they cancel because they're the exact same and one's negative, one's positive. But you see how F1 and F2 or F1 and F3 they have a difference here.
Oh, because of the rho naught plus A.
Uh-huh. So F3 is
Okay.
positive,
Never mind.
F1's negative, but they're not the same in magnitude. So
So you
Oh, for sure, for
can't
sure.
really simplify that, can you? It's just
So
how it is.
F2,
that's just how
F3.
it is.
F2 and F4. Okay.
Oh,
Yeah,
okay.
yeah,
Yeah.
that's how you get this because you want to
That's
prove this goal at the end of the day.
and then you're going on
So,
the negative A rho direction.
mm-hmm. Why is that? We're about to find out. So let's say we add, so basically F equals F1 plus F2 plus F3 plus F4. And this just equals F1 plus F3 because these went bye-bye. Ah, yes, they went bye-bye. All right, so we're left with F1 is basically this. There's a B over here.
Okay.
And then we have, let's see, plus F3. There we go. All right, just write that.
I guess it gets factored out. I don't know.
Yep, that's pretty much it. If you want to write it exactly the way it has right here, what we need to do is essentially multiply. Yeah, you factor out a
Yeah, they
minus.
factor out a
So,
minus, yeah.
mm-hmm. So we
And they
factor out a
attached it to
negative.
the row.
Mm-hmm. So we're gonna have a minus a row essentially. Factor that out, and we're left with let's see, mu naught I1 I2 over 2 pi rho naught. I think you guys can do the algebra at this point, right?
Yeah.
No, come on, do it for us. Do it for us.
Okay.
I'm just kidding. I'm just kidding.
All right, there we go. I want you to get your money's worth. Okay, so what we're gonna have left is basically
No, I'm getting my
you
money
factor.
absolutely worth right now. It's so worth it.
Sure.
So now we could take out the constant essentially.
Now I kind of
Um,
called Dr. Baker Unc during class.
Bro, he's the OG unk.
Yes. Do your thing, Unc.
His first name is Unk.
Yes.
Robert Unk Baker.
No relation.
okay.
Where's Thomas? I haven't heard Thomas.
He might have fallen asleep by now.
I don't blame him, bro. I
Nah,
think
I
after
don't blame
this, okay.
My voice put him to sleep probably.
That GPT is hold him captive.
Yes, sir. That's it. AP. Yeah, there you go. A row. I mean.
Yeah, Michael, are you happy that you did all this for us?
If it helps you guys, then I'm ecstatic. How's that?
Wait,
Electro-
what?
Definitely helps.
electrostatic, Michael?
Alright.
Okay. Now,
Did that
Done.
overstate you? Okay. Okay.
That's it, bro. We finished at 9:03.
So